Okay. I want to thank Gary for this invitation and the whole team of the Center for Interdisciplinary Research in Music, Media and Technology to invite me, and I am delighted and very honored by this invitation. And also I am very happy to return to Montreal, and I put a little piece of music. Yes, for French people, this song is very important. Okay. There is my name, but also there is, it will be necessary to add a lot of names of colleagues, musicians, acousticians, for different laboratories who participate with me to this research, but also a lot of students that have done most of this work. Okay. 30 years ago, the 11th International Congress of Acoustics was organized in Paris in 1983. 30 years after, here in Montreal was held 21 ICA. And this proposal to give a lecture here is an opportunity for me to revisit the theme of a roundtable that we had in Paris, which was acoustic and contemporary music. I don't know if you recognize some friends. There are Gabriel Wenreich, Tom Rossing, and a lot of people at this time in ICA in Paris. Okay, the round table was organized by William Hartmann with Michel Castellango, Pierre Boulez, Jean-Claude Risset, Jean Kergomar, and myself. A lot of contribution give a number of questions, some of which have been contributed later to my research. And there are two that I write here. The need for contemporary music to have a new sound. And with traditional instruments, you can hope to get through the novel use of existing instruments, with change of the instrument, but also to invention of new instruments. Also, the second point was the reproduction with loudspeaker. Generally, it's very difficult to reproduce a radiation of musical instrument with loudspeaker, and it was noted at this round table. And the third one that I do not note here was regarding the sound synthesis. Very little was discussed about sound synthesis, which was still in its early stage at this time. Okay, I will present some point about microinterval for woodwind instrument to create new sound, also multiphonic sound, the problem of radiation. I will say some word about mute of brass and string instrument, sound synthesis from physical principle, some word about the quality of tone and the quality of instrument. And will give some perspective, and I suppose there will be some question and discussion. There is different possibility to help musicians. One is helping directly. That means, for example, create a new mute or multi-loudspeaker device, or an advanced Max MSP patch, for example. But sometimes the interaction with musician is indirect through publication, a report, a conference, and sometimes you wrote some report about something and the musician use, and we will see some example later. Okay, microinterval system for clarinet. The use of microinterval system is not only the concern of non-European civilization, but also it's a concern of 20th century composer And one example that I choose is the example of ligeti, and with the piece ramification. And let me just play a little part of this piece. Okay. Okay. Excuse me. With strings, instrument is more, let's say, it's less easily to do micro-interval. In this piece, Ligeti wrote this piece for 12 string instruments, and 6 of these instruments are tuned a quarter tone lower. And if it's possible to do with string instrument, this thing is not possible to do with woodwind instrument, for example. And it's why we decide to work on micro-interval system for clarinet, for example. How to produce quarter tone with a standard clarinet? There are 3 possibilities: particular fingering, but all the fingering are not possible, and you have also a problem of velocity, virtuosity is difficult to play. One another possibility is to find sample device, open tube or closed tube, inversely proportional to the frequency that you had in the instrument. But in fact, you change a lot of things for musicians, and generally it's very difficult musician to use. And the last one is to insert an additional length inversely proportional to frequency close to the reed, and is what we have done at IRCAM. And let me show you the system. It's a very simple system. You have a pedal and a cable, and you move a piston on the mouthpiece, and you change the volume, the length of the instrument, in fact. Mm-hmm. If you are interested, there is a website. In fact, it's not working actually. Okay. There are some composers who use this device, for example, Marc Monet, excuse me, but also Mauro Lanza for the ballet of Angelem Pregiocage, Le Songe d'une nuit d'été, who use often this system. I have two sound examples of the possibility of this system. I hope you will have no difficulty in recognizing the musical illustration. This is the first one. And the second one. Alain Damien was a clarinet player, decided to play the sequence of Luciano Berio, but at this time Berio wasn't there, and I am sure that it will be interesting to use this device. Okay. One day, one weekend, in my house. Oh, excuse me, I'm doing a lot of noise. I saw on the TV a very strange thing. It was some imitator. I suppose it's a French imitator, Harry Bart. And you have the website if you are interested to see this video. But I have here a copy, a very bad copy that I record very quickly on my TV. It imitate two people who sing. Let me show you. Au sommet du Fujiyama, voir le pays du matin calme, aller pêcher au corps et m'enivrer de vin de palme en écoutant chanter le vent. Avant que marche ne se suze. Okay, Henri Salvador and Yves Montand, and I was thinking, looking at this, perhaps it will be possible to create some instrument with two personalities, that you add something in the instrument. You have, for example, a clarinet, and you change something, you obtain a saxophone. Why not? And we worked later on a device related to the micro-interval system that I presented before. A device which is not external, you don't add a length, but you change the inner volume of the mouthpiece in adding, for example, water with a special system. And when the volume decreases inside, a mute effect and a change in timbre, new for the clarinet, is generated. And you can see here this device that you put some water here, and you have a lot of changes of volume with water. Let me play some illustration, played by some jazz player, Massimo Caruso. It's a clarinet. Okay, for me, it's between clarinet and saxophone in some sense. Perhaps do not agree, but it will be possible to discuss later. But it was interesting to see that you can change the personality, and you have a different instrument with this simple system. But the only problem that with this device, the instrument is not play very well in tune. It's a problem for the musician. We build also a new device, not to change the personality of the instrument, but for the quarter tone. Let me just present this device. It's the length of the instrument at the barrel of the clarinet is motorized and controlled by a pedal with a motor, little motor, and you can change the length and change the tune of the instrument. This is another possibility. Okay. Multiphonic, it's also some phenomena that composers were interested to study, and there are a lot of things about woodwind instrument. For example, with Robert Dick, many years ago, we worked on a new flute. Robert was interested to build a new flute with all the different keys are uncoupled, which is not the case generally with the bump flute, and you can associate different keys differently with the bump flute and produce a lot of multiphonic. But you have to again learn how to take the flute, how to play this flute, and at the end, Robert decided that okay, no, it's not a very good idea, but it was one possibility. Okay, we were interested also on the multiphonic sound. With brass instrument, the trombone, at this time at IRCAM, two trombone players were there, Benny Schulich and Vinko Glboka, who was in charge of a department. And with Michel Castellango in Paris, we present some observation of this phenomena, but we weren't able to explain how to produce this kind of multiphonic. Let me play one very quickly example of this. It's some kind of roll sound, and we don't understand at this time how it's possible to produce this thing. And if you look at the movie of the lip of the musician, I'm sorry, this is upper lip and lower lip, yes. But if you look, I don't know if it's possible to see the aperture of the lip. You will see that it's not periodic, in fact. There is some kind of aperiodicity. There is no reproduction of the phenomena, and it was very difficult to explain this phenomena. By chance, there are actually people who are working on robotized artificial mouth, and also who are working on model of lips. And I hope that in the future, with, for example, a robotized artificial mouth for brass instrument, for the trombone here at IRCAM, it will be possible to explain the phenomena who are responsible for this oscillation. Okay, another work that we have done at IRCAM was about the mute of brass instrument. The trombone player, Benny Schulich, was very interested by this study because there are some phenomena that he doesn't understand. Sometimes in low frequency, with the mute, it wasn't able to play some notes. And it was interesting to understand what the phenomena is there. For example, in the Kammerkonzert of Alban Berg, for some low notes, you are not able to play with a straight mute, for example. And we study a lot of phenomena and publish some report on mute. All the acoustic phenomena, all what we understand. In fact, there are a lot of things that we don't understand still, actually. In fact, relate to the perception in particular. And this report was very important for a composer, a young composer at IRCAM, Jan Maresch, who was from the cursus, the training course cursus of 1993. And he used this report to write a piece for trumpet, mute, and electronic. And let me play some part of this piece. Okay. This is one direct interaction with the composer, and we were very happy of this indirect interaction, who produced very nice music for my point of view. A direct interaction was a composer who was interested to have a wah-wah mute for the French horn. There are wah-wah mute for trombone, for trumpet, but there are no wah-wah mute for French horn at this time. And we decided to build one and to calculate the shape, in some sense to obtain the effect, the timbre effect that we transpose from the trombone to the French horn, which is not very easy, but also to find a shape that would not modify the tuning of the instrument. This is a big problem with this kind of mute. You obtain some change of timbre, but you obtain also some modification of the tuning of the instrument. And we find a shape, not very beautiful shape, perhaps too big, but it was working perfectly in tune. And if some manufacturer will be interested, we can continue to calculate, to decrease the shape and to find the shape where the musicians say, okay, don't change everything, it's perfect, and I can correct everything. But this one is working perfectly. Let me play for you some example of this mute. The French horn player James McManama discovered this mute when we record, and it was recording in the espace de projection at IRCAM. It's very reverberant room. I'm sorry, but this is a wah-wah effect. Without the mute, with the mute, and now he tries the tuning in the low register. Okay, it's in tune. In fact, the volume is correct to be in tune. The only problem is how to bring this mute with you. Okay, but it's another problem. Okay, when we work on mute of brass instrument, I remember Pierre Boulez say that what is important with mute is also the weight of mute. And for example, if you look at the music of Webern, generally Webern associate one brass instrument with one string, which is not the case, for example, for another composer. Because every time Webern use mute for brass instrument. And the term weight is very important, how you can combine the instrument. And later, when we work on mute for string instrument, we try to understand what composers say about the width of the effect of the mute. We understand brightness, we understand loudness, but we do not understand width or openness, or I saw your last ICA term saliency. I think there are something there that were not clear for me. Okay, and for the mute of string instrument, the same composer, Jan Maresch, was interested to have a mute, only one mute who can reproduce the effect of all the mute. In fact, for string instrument, there are three mute, generally three mute. But the problem of this mute, they change from a mass of 2 grams to, let's say, 50 grams. And it's very difficult in one mute to change, and we try different things. We try this kind of mute that you can orientate differently, but the success is not very good, in fact. We have to continue to work on this for him. When we work for Jan Marash, I remember the question of Berriot. Berriot was interested by a mute, let's say a tambourine mute. That means when you play with violin or cello, you obtain also some kind of effect of small cymbal that you have on the tambourine. And we built this one. Okay, it's working, but it's not working. It's working for some string, not for all the string. I think it's necessary to work again on this. Okay, the next point is the radiation of music instrument and reproduction with loudspeaker. And I return to the round table discussion. I remember that Pierre Boulez, who was working at this time on this piece, Répond, says the loudspeaker anonymize the real source. And also the instruments are passed to the rolling mill of amplification. He has a lot of trouble with loudspeaker. And at the same round table, I present a very strange thing, not very strange, but I was working on mute. And to reproduce the effect of mute, you can record musician, and you have the effect on timbre, on tuning, but you are not able to reproduce one effect, is the effect on the radiation. And every time I was interested to show the effect of mute on radiation, I was obliged to call a trombone player, say, okay, come at IRCAM, try the mute. But at one time, musicians say, okay, thank you very much, but we have something more interesting to do. and I decide to record the musician in the mouthpiece. He play a little piece of music, and I play again the trombone with a horn driver on the mouthpiece, and play the music that I record on the mouthpiece. And I was able with this system to put the mute and to recreate the effect of the radiation, the effect on radiation of the mute. Later at IRCAM, a young composer showed me something very strange. It seems that it disappeared, but it seems that it was used in movie, when people play movie at one time. It's what they call resonateur Thomson. It's more diffuser Thomson. What is this system? It's a box with a loudspeaker inside, and at the top of this loudspeaker, you have a lot of tube, like an organ pipe, open tube with different lengths. And I remember at this time we played the cello suite of Bach with this system, and it was very nice. The realism was very nice compared to the traditional loudspeaker. And I remember that Gabriel Wenreich continued this work and proposed another system of loudspeaker to recreate more realism in the reproduction. Okay, this different point led us to investigate the influence of radiation at IRCAM, and with my colleague Olivier Warusfeld, Nicolas Misdaris, and other people, we work on the radiation of musical instruments. We know that it's complex and variable. The problem is cannot be dissociated of the acoustic environment. There is an effect on diffuse and reverberate space There is also an effect on perception, variation with position of listener. And this is a problem with mixed music when you have a real instrument and a virtual instrument or transformation of sound with loudspeaker. It was the case of Répond for Pierre Boulez, for example. We have done a lot of measurement on particular, in this case was a saxophone, a woodwind instrument. You excite the saxophone with a loudspeaker and you have to measure in an echoic room the radiation on the sphere for all the fingering, for all the frequency, and it's a lot of work. It's very difficult to measure. And sometimes it's possible also to use modelization of radiation. And what I present here is some measurement of radiation of the saxophone. You can see there's the saxophone for 1000 hertz and the free fingering. That means the musician do not put his finger on the saxophone. And you have here a second measurement for 2000 hertz. The model and measurement, you see that there are some correspondence. What is possible to see there, that you have a lattice of tone holes, and there is a frequency. There are different frequencies for the radiation, excuse me. One, it's when the instrument change and is not omnidirectional and start to be directional. And this is related to the lattice of tone hole. That means the size of the hole and also the space between the different holes. And you have a free band of frequency. One it's omnidirectional, one in higher is very directional, and between the two, the instrument radiate on the side, and it's possible to see the instrument radiate on the size of the instrument. It's possible also to see that our model is not correct here. It's in fact due to we don't take in account in this model the interaction, the external interaction of the tone hole. When the tone hole radiate, they radiate in the room, but they radiate also in the other hole, and they exchange a lot of things. Okay, to reproduce this effect, we use a system of multi-loudspeaker. For example, this one, it's 12 independent loudspeaker based on a dodecahedron. And we try, for example, on the movie that I will show now, to reproduce dipole for all the frequency, all the frequency of the saxophone. Let me show the movie. I don't know if you see, yes, it's possible to see the frequency. It's approximately dipole, but at one time, there are very strange things who appears. And when you increase the frequency, okay, the dipole has a strange pattern. Okay, and now it's not a dipole. There are people who are working on this subject at IRCAM and try to use a lot of loudspeakers. There are people also who are working in Berkeley. I remember David Wessel has done a nice experiment with this system. It's very important to have this kind of system to try to reproduce this, but it's very complicated. And it's not working actually. Okay, perhaps the next point will be virtual instrument. We have seen a lot of things about real instrument, but at the time of the round table, what I said before, it was very difficult to think that in the future virtual instrument will be very important, and that it will be possible to use sound synthesis in real time and to have the same effect with a real instrument. And at this time, at IRCAM, I don't know who has done this, but there is a questionnaire who was sent to a lot of composers, and the questionnaire was the computer, has it become an instrument with possibility comparable to the possibility of traditional instrument? The questionnaire was sent in the late 1980, approximately, and I have put only two answers. One of Tristan Muraille was very interesting. He said that the computer become more and more instrumental, and the instrument will be enriched by small computerized mechanisms. And I will show you later some example. But also the answer of Marco Stroppa, and say that, okay, you have to go to school and study how to use computer, which is not the case actually. In fact, young composers use more and more software and computer for all the things. At this time, at IRCAM, we work on the software, the Modalis, with software from physical principle. Our laboratory is measure instrument and do also some model. And I give a brief history of the project. It was an open environment with the purpose to serve as a virtual instrument maker workshop. It means you take a tube, you take a bow, you take a plate, you combine all this, and you create a new instrument. For this, we use a modal formalism, who offers several advantages. The first one, it's a uniform description of mechanical and acoustical system, allowing easy hybridation between the two. For example, you can blow in a plate, or you can blow a tube, for example. Okay, the modal description is frequency, damping coefficient, deflection shape. And to obtain this, it's possible to use analytical solution, but also measurement, and also numerical methods such as finite element method for both structure and field. And okay, the block diagram of Modalis is like this. You have some object, and you play this object interaction. You strike, you plug, you blow, you bow, and you have controller who controls what you are doing on the structure, and you have at some point you put some virtual microphone to obtain the sound. There is no radiation. In fact, we take inside the instrument the vibration of the plate or the vibration inside the tube, for example. I have a basic example just to show what we are able to do. To plug a string, to strike a plate, okay, to bow. Some example of hybridization. And here it's more difficult. It's a bass clarinet that we have produced with a finite element model. Not very in tune. Okay. Okay, to do this, you have to measure the instrument very quickly. You have to dissociate every part and try to build again and to have an instrument which is very difficult. Okay, and you have also some molding of the tone holes. You measure very precisely, and you obtain a bass clarinet mesh. For example, this one was a 1200 element, and that is possible to play not exactly in real time, in fact. When you open 5, 6, 7, 10 holes, okay, it's possible to play in real time. When you open 32 tone holes, there are some trouble, actually. But we are not very far from real time, and for a virtual instrument or imitation of the bass clarinet. But the big problem when you reproduce some instrument, or when you create an instrument like similar to the bass clarinet, you have to know how to use. And the musician is very important. It's necessary to write all the fingering, and especially for the bass clarinet, sometimes in high frequency, you have 7, 8, 9 possibility. What you choose, you don't know. And also to validate the model, we have measured the resonance frequency of the instrument with input impedance device, and the musician has to sit down with the system to measure with there, and we measure all the frequency to validate the model. Okay. In fact, we are not very far to have a new instrument that we are able to play in real time. And I choose some example which not relate to instrument, is relate to, it's an instrument, but it's a lady who dance on a plate. On this plate there are some sensor, and these sensors are related to the software. And she can interact in real time with the software from the plate. Let me show you this example. It's a piece of Lorenzo Paglielli. Okay. In fact, it's some example of a new instrument in some sense that you can use, and it's related to computer. Is what 30 years ago it was very difficult to imagine this possibility in here. Okay. The problem with sound synthesis from physical principle is when you use some instrument like the bass clarinet, the violin, cello, flute, trombone, instruments who are self-oscillating system, it's the problem of the control. You have to control every time what you are doing when you play the trombone or with the violin. It's not like with a plate, when you strike a plate, you don't control every time. You have a discontinuous control. And the big problem is to understand what the musicians are doing and what you have to do on this virtual instrument. And I just show you something that I suppose a lot of people here know, because it was done here in your laboratory with Marcelo Vanderlei. It was a measurement of violin player. What was measured? What was measured? The inclination of the bow velocity, the bow force at the point of contact of the string and the bow, and we developed a special system to measure this. It was not very easy, and perhaps for people who do not have seen this, I will play very quickly some example. Okay. From this measurement, it's possible to find some rule to control, for example, the violin. And if you use this rule to control, to pilot the synthesis, you obtain a very good realism of reproduction of the sound of violin. Okay. Perhaps the two last points that I would like to say some word. Yes, it's about quality of tone of real instrument and also virtual instrument. I have done some work on the piano many years ago, and I was interested in the quality of tone in the medium register of the piano. In the medium register of the piano, generally, when you record the sound, you have a double decay of the sound, which is not the case in the high register. In the high register, you have a very strange thing, chaotic thing. There is no possibility to model, and in low frequency, it's another problem. But generally, what you obtain in the medium register, if you plot the relative sound pressure in time, you obtain this double decay, well-known double decay that Gabriel Weinreich explained and give a model of this. But in fact, if you are more curious and if you enter into the sound, you open the sound and you look at the first partial, the second, the third, the fourth, the fifth, what you see that the first partial, it's okay, you have a double decay, approximately. If you look at the second partial, the light green, you see that perhaps it's difficult to see. Perhaps the third one is more easy. You can see that you have a hole there. The fourth, etc. You have some kind of amplitude, things like this. And what we have done, we have released, for example, the red one. We have decided to remove this part, this hole, and synthesize again the sound. And when tuner of piano heard this, they say, okay, it's not the sound of piano. You add something. In fact, we were surprised by this. And in fact, the quality of sound is something that we don't know exactly, for example, for tuner, what that means, what they hear. And I think perhaps it's the same for virtual instrument when you create new sound. What is the quality of the sound? What we have to hear to obtain good sound? And I was very surprised because I found some article of Harvey Fletcher in 1970, something like that, who has done the same study than me with the tool that he had at this time, who are not very good, and he synthesized also some sound, and he found the same thing. He tried to explain, and it was an interest on this quality of sound, and I was very surprised by this. Okay. Quality of instrument. This is a big, interesting question that in the laboratory or Gary are doing a lot of work on this. We have done this, let's say, 20 years ago for the trumpet player. but it was very complicated. It was very difficult to obtain some result. I was surprised because the trumpets were very good trumpet, and we decided to add not a very bad trumpet, but a trumpet not very in good condition of one of our colleagues, and the musician don't say anything about this trumpet. They say, okay, perhaps it's not perfect, but they don't say it's very bad trumpet. I was very surprised. Perhaps our method wasn't very good at this time. Okay. Yes, it was a work that we have done on bow and on bow comparison of bow. It's David Grimal. It's a violinist, very good violinist, and also it was very difficult to find something. We find something, sure, but not to explain what the musicians say. David Grimal is a special violinist if you are interested to imitation of violinist player. It's very nice. He can imitate David Oistrakh, Jas Fest, Shlomo Mintz, Perlman. He understands everything what the musician is doing with, for example, a Fest use only the velocity, not only the velocity, but most of the control of a Fest is related to velocity. And David was able to reproduce the sound of a Fest of Oistrakh. It was very, very nice to work with him. But we do not obtain conclusion on the bow. Okay, no, perhaps this one we go further. Yes, the same problem with the quality of virtual instrument, how to evaluate the quality. And let me give some perspective. I return to the remark of Murray. Murray say that perhaps it will be possible on traditional instrument to introduce some electronic device, computer, something like that. Like actually in the car, you have a lot of small computer for different things, and in the instrument it's not the case. And the idea of Murray was very interesting. And actually, there are people who are working at IRCAM. We have a group who is working on active control applied to musical instruments. That means you had some piezoelectric actuator on a plate, and if it's actually it's not working very well, but the idea was to change the different resonance of the plate, change the frequencies, change the Q factor or something like that. And the same with wind instrument. That means you have microphone and speaker, or for example on a clarinet, on a bass clarinet, and try to change the resonance frequency to move some frequency, and I think it will be a good idea to return to what I said before about the instrument who change of between clarinet and saxophone. I don't know if it will be possible, but it is very interesting to work on this subject. Okay. Yes, there is also something related to Murray. We have done some work on automatic tuning mechanism of the timpani. If you look at some instrument, you are sometimes very surprised. And the timpani, it's a case. You have to tune with a pedal. It's not very precise. You have to look at a small piece. Okay, it's in tune. It's not in tune, and it's very difficult to change. And I don't understand why in 2013, excuse me, at this time, we are not able to have a new instrument with a system who are working more efficiently, in fact. Okay, the reproduction of radiation, it's an open, also open question. And I suppose people who are working on high order ambisonic and wave synthesis are very well, they have the possibility to make some amelioration of the system of reproduction. Okay, for the virtual instrument, there are a lot of things that we have to do. What I described before, it's what we call it's a linear description of the vibration of instrument. But when you blow very high in a tube, or when you strike a plate, or when you plug a string, you have also nonlinear phenomena. And actually, we are not able to describe and use in sound synthesis. And I hope that in the future, it will be possible to introduce a nonlinear phenomena in virtual instrument. And the last point is the control and quality of virtual instrument. And I have finished.